All right, welcome. Today, we're going to crack the code on a real AQA GCSE Physics exam question. And we're not just going to glance at it. Oh, no. We are going to dive deep, get right inside the examiner's head, and figure out exactly how to lock in every single mark. So here's our game plan. First, we'll decode what the question is actually asking. Then we'll scoop up some of those quick and easy marks on energy stores. After that, we'll tackle the bigger comparison question, then the explanation question, and to finish it all off, we'll talk about how you can truly master the mark scheme.
Okay, first things first, let's get the scene. This whole question is built around a massive, real-world physics problem. What on earth do you do with all the energy you get from renewables when you don't actually need it right that second?
And here's the star of our show, a wind turbine. It's fantastic when it's spinning and making electricity. But what happens on a really windy night when everyone's asleep and not using much power? That's the problem. And this exam question looks at two possible ways to store that extra energy. One is by heating up water, and the other is by pumping water up a hill. Right, the first two parts of this question are designed to be quick wins. We're talking one-mark answers. They're testing your fundamental knowledge, and the absolute key here is using the precise scientific language. Let's take a look. So, question 1, straight from the paper. Which energy store increases when water is heated? It's a pretty basic concept, really. Just think, what's happening to the actual particles inside that water? And here's what the mark scheme says. This is so important. You could write thermal energy or internal energy. Both are perfect. You could even get more specific and say the kinetic energy of the water particles is increasing. Any of those three gets you the point. Easy. Okay, on to the next one marker. Which energy store increases when water is pumped uphill into a reservoir? Again, this is just testing if you know the name of a very specific energy store. And for this one, there is only one correct answer: gravitational potential energy. And notice, you need that full, precise term. If you just write potential energy, you might not get the mark. You have to be specific. And just like that, we've got 2 marks in the bag. Okay, now we're getting into the real meat of the question. This is a 4-mark comparison, and this is where you need to use the data they give you to build a solid logical argument. Look at this. Everything you need for the next 4 marks is sitting right here in this table. We've got our 2 methods, A and B, and the table tells us how much energy they store, how much is wasted, and what it takes to install them. Now, the question asks us to compare them. That's the magic word. It means we have to look at the good and the bad for both. Let's just break down one key point: efficiency. The data says method A wastes 40% of its energy. So a quick bit of math tells us it's 60% efficient. Method B, on the other hand, only wastes 25%, making it 75% efficient. Just stating that method B is more efficient is an absolutely crucial point you need to make in your answer. So here's the secret to getting all 4 marks. You need a balanced argument. You can't just pick a winner. You'd say something like, well, method A stores a massive amount of energy, but it's less efficient. Meanwhile, method B is way more efficient, but it stores a tiny amount of energy in comparison, and you can only build it in high mountains. Using the actual numbers from the table, that's what takes an okay answer and makes it a top marks answer. Okay, let's break down the final part of question 1. This is another 4-marker, and it's asking for some practical, real-world changes to cut down on carbon dioxide emissions. And the question is super clear. It wants 1 change for transport and 1 change for generating electricity. That means we need 2 completely separate answers here. The key is to be specific and give a valid example for each one. So, for transport, the mark scheme actually gives a whole bunch of acceptable answers. Any single one of these would get you the points. You could suggest using electric cars or taking public transport. You could even go with really simple options like walking or cycling. They're all direct, practical, and correct. And for the electricity generation part, here's the list of valid points right from the mark scheme. You could talk about moving away from fossil fuels and using renewables like solar or wind instead. Nuclear power is another valid answer. Or you could make a really smart point about just using less electricity in the first place, by not leaving appliances on. Again, any of these will get you the marks. So we've completely dissected that question. Now let's just pull back and look at the big picture for a second. What did we actually learn about how to tackle these exams to get the best score possible? Because it's not just about knowing the physics, is it? What you should be taking away from this is a clear, repeatable strategy, a blueprint. First, hunt for those keywords. Does it say compare, explain, calculate? They all mean different things. Second, if they give you data, you have to use it. Quote the numbers. Third, be specific. Vague, waffly answers get 0 marks. And finally, structure your answers so you tick off every single part of the question. That's the formula for success.
At the end of the day, we've seen that understanding the mark scheme is just as important as knowing the actual physics. When you can decode the question and see exactly what the examiner is looking for, you can turn what you know into marks every single time. So the only question left is, what topic are you going to go and master next?